Good morning. Thank you for joining our session today. My name is Eric Trower, and I'm a member of the marketing team at SICK. SICK is the leading provider of sensor solutions. Today, Bill Colwell, Account Executive for Logistics Automation at SICK, and Bryan Duncan, National Business Development Manager for Storage and Conveyor at SICK, will be covering the topic of innovative uses of cloud data to improve fulfillment and distribution center volumes. They'll discuss practical applications of how you can use cloud data to improve conveyor flow, avoid jammed lanes, and even increase warehouse worker accountability. If you have any questions during the presentation, please be sure to type them in the Q&A box in your WebEx control panel on the right-hand side, and we'll take time at the end of the presentation to address as many of those questions as time allows. Lastly, I'd like to mention that following today's presentation, a recording of this webinar will be emailed to each of you, as well as those who registered but may not have been able to attend. So without further ado, I'd like to turn it over to our presenters, Bill and Bryan. Please take it away.
Hi, my name is Bill Colwell. I'm an account executive for SICK. My focus is on logistics automation. I've got a background in controls automation, engineering and designing both factory automation and logistics automation systems. And I'm also an architect for cloud space. So that's what I'm presenting today. Bryan?
Yep, thanks, Bill. So I'm Bryan, and my background is in solutions development and implementation and logistics automation. I've been doing this for about 20 plus years. I'm happy to be here to talk about things that actually happen in the distribution center.
Okay, so Bryan, I guess I'll start it off. So before we get into what I consider specific use cases that pretty much apply to all distribution centers to recover lost volume, I'm going to just talk about some of the key components. So I'm just going to verbalize some of these screens. So, you know, every warehouse, distribution center, cross dock, they all have data. You know, this data supports the material handling equipment and the visualization systems. So basically the sensor data is already there for the material handling and those vision systems. But you have actionable data that is the data that can, when being used in a smarter manner, allows you to do smarter, more creative, more predictive things with that sensor data to improve the or optimize the flow through that distribution center. So as the diagram details or the image details, there's the capture item, there's the management taking that and really figuring out what you can do with that data that you haven't been doing it. And what I consider one of the important elements is the data mining. So even if you take the existing sensors and you supply this data to the cloud, there may be reasons for your data scientists to accumulate this data, invoke better predictive lane allocation, talent designation, and labor allocation. So this is a long-term process, but if you don't have the system in place and you're not able to utilize this big data. So the use cases that we're going to talk about today are going to show the utilization of this data, how we utilize this data.
So Bill, would you, the bottom line is enabling the highest possible volume to flow through the facilities?
I'm sorry, I didn't hear you, Bryan.
Would you, so the bottom line, would you say that that we are enabling, that the technology enables the highest possible volume to flow through the facility?
Yeah, absolutely. The material handling systems that are in place today were designed to take discrete inputs from the field, know where cartons, totes, packages were, do the proper diverting at the right place, gather information about those containers, and then make sure that the products made it from the receiving to the shipping. So, material handling's come a long way, but the systems and the artificial intelligence and the predictive nature of better designation of labor, has only come about since the advent of cloud services and the associated intelligence of using those services. So today, I'll speak very briefly on some of those cloud services. The reason we talk about them, the reason that distribution centers or distribution networks are using these are because they're scalable and they're easily utilized throughout all the distribution networks or all the distribution centers or cross docks in a network. So they support, these web services support the WMS function, the WCS function, and some newer functions that relate to the data analytics. So briefly speaking, there's when we employ these type of technologies, you use things like the S3 storage, and some, by the way, some of these web services relate to naming from the AWS services, but Amazon's web services are not the only solution. There's many out there. There's Microsoft, there's Google, but a lot of what I'll be talking about today will only pertain to Amazon Web Services, but all these strategies are certainly not limited to the Amazon solution. So with the S3 storage, it's this storage where, for example, if you're storing images and these images are going to be used for illegal for trade or damage claims, it's a very efficient way of storing these images. Lambda functions is the web service that basically is the logic. It creates the triggers. It senses what's happening in the DC off the sensor data and generates the appropriate actionable items. This can be sorters diverting. This can be alerting to problems in specific areas. This can be alerting people to move to a different part of the conveyance to better utilize that conveyance. There's the machine learning modules, web services. The utilization of the machine learning can take all the sensors from how the material handling equipment is diverting, sensing the chemistry of what cartons and totes and packages are on that conveyance, and maybe inducting to different lanes to utilize that conveyance better, or also utilizing the understanding it knows where the associates are and more efficiently processing the containers to those areas or those gates and the lines. So you also have SNS, which is simple notification service. This is what creates these messages to operations, control teams, maintenance teams, to tell them that there's a problem, there's something that they should take a look at, something's affecting the volume flow, becoming a volume impediment. So these messages using cloud services can be a source of text messages, emails, even radio calls throughout a typical Motorola radio system that you'd see controls and maintenance and associates carrying in the distribution center. RoboMaker, this is a web service that allows you to do a better job of maintaining your fleet of mobile platforms. These could be automated pallet jacks, automated forklifts, mobile pick robotics, and to make sure that there's not collision, to make sure that each one of these devices are navigating in the most strategic manner to allow the optimal amount of product to move throughout the distribution center. DynamoDB, this is a high volume, low latency database where you would want to store a lot of this sensor data. The key to low latency is, these days it is a manageable thing. It is an acceptable thing to store all your sensor data into the cloud because the networks are quick enough and the database, the software is quick enough to manage that data. You also have EC2. It provides secure and elastic cloud computing capacity. You have
Hey, Bill,
go ahead.
I have a question. So why utilize EC2 and why not just use the DC server room?
Yeah. Well, from practical experience, I can tell you I maintained a lot of server rooms in a specific retailer's network. And, you know, there's something to be said for having to maintain the server rooms in all facilities. You have to keep the register license up to date. You have to take care of maintenance and run the software to monitor the hardware. And when your infrastructure is in the cloud, your SLA contract basically states that you're guaranteed that all these functions, all these network related maintenance functions are going to be taken care of you. But really, for me, it's three major advantages: data availability, data durability, and to me, the most important is the elastic component of using EC2 type services. So EC2, for anyone that doesn't know, it's basically your server. It's your server in your cloud, your what's running your process. But like EC2, you know, you have your bandwidth, your internet connection, you have your memory. So when it's elastic, you know, it grows or shrinks as you need it, and you pay for it. A retailer will pay for it proportionally. So, you know, the last thing I wanted to do, you know, when you have an integrator place the material handling equipment in your facility, it's not really until you run into your peak season that you really test the messaging system and the material handling software. So this is where you run into, especially with new build, you run into problems. Well, my sorter's gone down, my pick lanes aren't working like they're supposed to, I've lost a line. And so when you have your control and your monitoring logic in the cloud, your server processes increases automatically as that peak increases, your memory increases, just everything, and your internet connectivity, so you have bigger pipes. So it basically relieves you from the worry that your initial hardware installation runoff was not enough to really test your facility. So it's a big point. So your IoT core is basically, well, I didn't mention earlier, the IoT Greengrass is basically the component that allows a device to communicate safely and securely to the web service. You know, this was a big holdback in the retail industry because, you know, basically people were worried about the security of the data, the vulnerability. So with protocols like MQTT, you know, it pretty much guarantees that your facility is not having to worry about hackers getting in and stealing information about the inventory, about what customer ordered which item. But getting back to the IoT core, that's the main Greengrass, in this case, connectivity module that allows your sensor data to seamlessly get connected to the cloud and allows you to populate your databases and to run your Lambda functions that either alert you to problems or basically runs your material handling equipment. Last thing is there's API gateways that allow you to do more custom involved control and monitoring of your facilities. But, you know, I've mentioned what, 10 services out there. There's hundreds, these days, hundreds of web services out there. But all of these services have allowed us to basically migrate a lot of the intelligence from a distribution center across dock, from the control supply chain management servers to the cloud. So once again, before getting to the use cases, you know, what this does is this brings two things into play. This brings better visibility and better accountability. So with better visibility, when you can have your sensors with better real-time monitoring, more granular data because you're putting more sensors out onto that material handling floor and better able to monitor it. You're extending the material handling utilization to be able to react more effectively for the things that cause volume losses, these volume impediments. And it also allows for better logistics planning, which I'll get into a little bit later, but it also supports the adequate reporting methods. So when you work in a one of these facilities, typically at the end of the shift, you'll either have associates or some level of operations go around, look at HMIs, come up with the information, put it in a spreadsheet, have operations meeting, merge it into a larger spreadsheet. Having that sensor data available to you in a more efficient manner, having it in the cloud allows you to pre-populate reports, allows you to generate automatic reports. So that's which ultimately allows for better visualization of your process. So another point is if that information is available, it better supports the operations teams, the maintenance team, the controls team, because now instead of getting a message over a radio that something's going on, they're having these unsolicited messages that says, hey, something's affecting this area of your material handling. You should address it and address it now.
Elaborate a little bit more on transparency in the DCFC environment.
So once again, labor is labor. There's a human aspect to it. And, depending on the time of the year, is it right after a lunch break? How is somebody feeling? Your material handling equipment gets addressed differently. If there's a problem, even if you're starting a sorter on time and the associated operations function to monitor the people that are monitoring the material handling, basically when somebody addresses an issue, hopefully they're going to address the issue immediately, remove the impediment, but that's not how it works in the real world because of these other scenarios that I mentioned. And so, when you have better data visibility, it allows you to do a better job of evaluating how your operations team, your control team, your maintenance team, your associates reacted to specific situations that related to lost volume. So these better visibility gives supply chain management a better understanding of how their facilities are running and how problems were addressed. To date and in the past, sometimes this information didn't flow to the supply chain as quickly as it could have, or maybe the team is supporting the team and providing some of this information will reflect in negative evaluations of certain teams. So having this kind of visibility removes that element of protecting teams. What it does is it allows supply chain management to focus on what's needed to get the teams to better respond to these issues.
Okay.
So with better visibility, which means you have a system in place now that basically populates the cloud and lets you do more creative things with it, and your system analysts utilize that to do better things with logistics planning. You now also have that accountability aspect, and so traditionally when you react to something, you have beacons, you have horns, but with the ability to send unsolicited messages from the cloud and also update displays and dashboards, it gets everyone involved quicker. And it not only sends these unsolicited messages, but it allows you to keep track of how long after the message was sent to the appropriate team or associate did they respond, or did they successfully remove that impediment affecting volume? So it helps to allow everyone to understand there's truly accountability now, that when you're messaged, when there's something going on, that you do have to react. You do have to react in a timely manner, and that the operations teams that are supporting that activity as well from a supervision point of view, that they've got to do their part to make sure they're clearing obstacles so that those teams are doing what they can to remove those obstacles. And since now this database is populating, since the sensor data and this event data is now in the cloud, it's just as valuable to your supply chain management through HTML 5.0 compliant dashboards as it is to the people on the floor, as it is to the dashboards on the floor. So this means that people can react, hopefully in a supportive way, quicker when you have a problem. And the last thing is, and it kind of relates to accountability, is when you have this data, when your system is experiencing events, it has all the data associated to events. So in a typical network, depending on the severity of the problem, you're going to have your severity report, and you're going to have a meeting after the fact to discuss what happened, what were lessons learned, what are we going to engineer into our process, so hopefully we don't lose this volume in the future. So when you have the data in the cloud, you can pre-populate these reports with pretty much everything except the plan of attack for the next time around. So having the proper visualization and now the data to support the accountability, it's supporting the efforts you need to reduce the volume losses within the distribution center. So as far as the hardware that's on the floor, the cloud information doesn't relate to just sensor specific type of like photo eye sensors. On the floor, you have a track and trace function that may incorporate RFID, barcode scanners, barcode cameras, and you have the photo eyes safety systems. You have the beacons that try to enunciate when there's a problem out there. These are all devices that can either be monitored or controlled via your cloud systems and your cloud strategies. Traditionally, these sensors out there were solely to support the WMS and the WCS systems, but now truly they're available to support your cloud-based decision-making. You also, with the advent of the sensors and the transmission of that data cloud, you need your edge connection devices, and you also need your IoT core, like a Greengrass device driver, to support the transmission of that data to the cloud. But these are all things that are there and in place to utilize in this day and age. So now let's get to the meat of the presentation today, and these are use cases. These are, where are we using these cloud advantages, these cloud strategies to remove volume losses. And these are only a couple. I may detail some of these more than others, but certainly I think I have maybe 8 or 9 of these, but literally there's 20 or 30 of these use cases that we've already developed and implemented. So one of my favorites is full lane conditions. So when I walk through a distribution center, which is part of my job, engage the hardware, check the SICK equipment, but also, because I have a background in controls, I always check, the flow of the hardware through the material handling system. And, one thing I can always do is walk to a sorter and see lost volume. Either there's issue with full lanes where product is having to be recirculated, or, a true indication of that is you ask the one of the controls guys or maintenance guys, what's the recirculation number? And when it's something above 3, that product's recirculating more than 3, you know that facility typically has problems with manning of the takeaway lanes, because as soon as those takeaway lanes are full, you're no longer able to divert on those lanes. You have the associated additional product. You have less inducting because there's already product on that conveyance. During peak season, you get into gridlock. It means you need extra labor up there pulling boxes off the conveyance. So that's why, one of the first places I check for lost volume is on sorters. It could be receiving, it could be replenishment, it could be outbound shipping sorters. So the value of adding, either adding additional centers or utilizing the sensors that are already out there that are used to indicate full lane conditions is they're there to support the material handling, but with our strategies, 6 strategies, it's just as easy to add full lane sensors or to split off those existing full lane sensors for pallet lanes, for gaylord lanes, for fluid load lanes supporting the trucks. And so by using some data concentrators or data hubs, typically like IO-Link, you have the ability to send this data through a internet gateway, populate the cloud, and now you have the visibility to support minimally just dashboards. But in the case of the facilities and the retailers we've been working with, the value really comes with the accountability aspect. We take that value, both the supply chain and that facility sees instantaneously when the takeaway lanes are in a full state, how long they've been in a full state. They see that a message has been sent to the people supporting those lanes. They see how long since it's been that the message has been sent to the appropriate associate or whoever's handling that lane. And depending on how long it's been, it also sends it to the appropriate supervision. So we keep track of those KPIs. In some cases, we keep track of how much lost volume occurred at the end of the shift or at the end of the day. So visibly, it gives them a better idea of, the problem they have at their sorter that ultimately cause for inefficiencies in the sorter, the inefficient inducting and the backing up upstream, which can affect some of your scanning of receiving lines. So this is one of my favorites because a cost-effective implementation of this type of system can almost immediately recover 20 to 30% of lost volume.
Now, Bill, this can be an overlay system as well as it can be connected into an existing control system, correct?
Correct. 6 sensors give you the capability of tying off to that signal. They give you the ability to both support the discrete connection to a PLCs or a sorter PC, as well as a second connection or a second pin going to a data collection hub. And so the value of this is, one of the first questions I get from a general manager is, what is involved in implementing this type of system and what's the risk factor? And I'll typically walk them out to the floor and I'll say, okay, here's a connection to either your current photo eye, if we put a newer SICK photo eye. If it's not a SICK device, it's the same connection, disconnect it, connect it, voila. If you have to unconnect it, connect it to the original cable, that's your rollout, that's your risk. But it's a quick process. It doesn't take a lot of downtime because it's just the disconnection and reconnection of another cable. It doesn't, in most cases, it doesn't really include the use of the integrator that supported the installation of the original equipment, because really what we're talking about are these cloud solutions are pretty much standalone. So they're receiving shared information from those sensors supporting the material handling, but they're really standalone systems. So it makes it very easy for implementation.
Thank you.
So from my background in supporting jam lanes, that's, there's the essence of lost volume, because now that conveyance isn't available and you're having to divert or that line stops. But there's also in some cases safety issues. You can get, depending on if it's like a horseshoe or supporting induct into a high-speed sorter. When the boxes jam, you can get volcano boxes flying, and that can cause a safety issue. But once again, it just gets back to this human labor. It gets back to the fact that people are going to respond to these volume impediments as they see fit. And like I said, depending on the time of year, which shift, are they feeling good that day? Is the supervision, the operations team there keeping an eye on things? Jam states can last, anywhere from 5 minutes to maybe, believe it or not, 20 minutes. So when you have, like in this case, same type of scenario, you're monitoring a jam condition, you're sending a unsolicited message to the associate or to the maintenance department. You're keeping track of it. If it takes too long, you're also sending messages to operations to motivate the people. Ultimately, what you're doing is you're exposing maybe vulnerabilities in your material handling so you can address those in the future. There may be a problem with O-rings or the initial design, but ultimately you're getting people to that spot. You're getting them to clear the boxes. You're getting that line up and running again. Another use case is packing or picking. Associates need supplies, they need support. There's various systems out there on the facility to gain the attention of the operations teams. Typically you don't want somebody having to leave their station, because that means that they can't do what they need to at their station. But in a real world condition, depending on all those human elements, they get responded to in such a specific elongated time period. So even if you have a facility that's been set up with the beacons to alert people, or even horns or audible functionality, it eventually turns to deaf ears, or people just don't look at those beacons. When you have a system that basically prompts the appropriate support team or spiders or the people supplying boxes or materials or any type of support to those people working those specific stations in a more timely manner, that means those people are going to be able to do their job in a more efficient manner. And these things have an accumulative value. So efficient inducting of most sorters. So this has NDC applications of utilization of web services, but it also has some network implications. So if, in a traditional DC, when you're merging, you have your merge lanes or you're inducting into a sorter, you have a couple sensors, but truly what those sensors are doing is being utilized to release slugs onto a sorter. So a sorter, typical implementation of these sorters are not that intelligent. They're round robin, release this lane, this lane, this lane, this lane. Maybe I'll put in some perceived intelligence where we can use timers so that if a lane that doesn't have any product gives us ability maybe to switch to the next lane quicker. But really, when you add additional sensors to your induct lanes, and you have a better visibility of the chemistry of the support lanes feeding that sorter, supporting those merge lanes. You can do a better job of saying, not releasing slugs in a round robin manner, but seeing that, okay, this lane is almost 100% utilized, release it, it's still at 100, release it. Okay, now it's down to an 80% utilization. Let's release this other lane that's 90%. What you're trying to do is you're trying to reduce the amount of gaps in that sorter, because the more product you move through that sorter means the more product you're going to get to the takeaway lanes. And if you're supporting those takeaway lanes appropriately, then that means that product's going to support quicker fluid loads and quicker pallet builds to allow more product to move throughout that facility. So this intelligence, as far as doing smarter inductance, which can be done from the cloud, it also gives supply chain management almost an instantaneous, if not a big data look at how they're merging into their sorters throughout their network. This data is vital to the data scientists and also operations to do a better job of predicting, which products should be sent to which induct lanes, and maybe even which associates should be on which lanes to move more products through that facility quicker. So, and once again, as you improve the efficiency of the inducting your sorter, that allows more product to move upstream, which allows those upstream processes to be more efficient.
So Bill, a question. What is the extent of the hardware topography involved?
So it's pretty simplistic. You either have your existing sensors out there, or you have to add some sensors to get better granularity of what's happening on your conveyance. But you typically bring it into a data concentrator. You have a bunch of data concentrators being fed into a internet gateway. These internet gateways have all sorts of flavors, but ultimately what they're doing is running a green grass type core. The service that runs locally in that facility that preps the data and secures the data, both static and for transmission, so that you can easily move that data into a cloud VPC, a cloud environment, and the associated database where that data is going to reside. So there's not much to it. It's in one way, it's truly not rocket science. Okay, next screen. So there's a lot of utilization of discrete sensors, but what we're also seeing is more use of products like LiDAR, and the data from LiDARs can just as easily be utilized in the cloud. Many retailers are saying, hey, let's slap a band on our associates' hands. Let's keep track of where they're doing. Are they in the area where they're supposed to maintain the hardware, so you don't have things like jams, which can cause problems to your conveyance and your sorters? Are they being efficient with their function? But that runs into all sorts of problems, because then you can associate a specific person's identity with that cloud-based functionality. What we're seeing is, well, no, what we'd rather do is we'd rather put in more cost-effective LiDAR devices that can still keep track of something in that area working, doing their job, moving packages, and basically either shutting down sorters if the people aren't there, or alerting operations that somebody's not in their work cell area. So it doesn't just have to be a discrete device that's being utilized by the cloud to improve volume. So another one of my favorites is walking through a facility, looking at their accumulation lanes, seeing where gapping is an issue. You know, the problem with poorly gapped conveyance and accumulation is not just a problem with jams in the conveyance. It can have ancillary effects like when those containers get to even the high-speed gapping bed, there's not enough gap so that you can't gap it appropriate for a scan tunnel. If you can't gap it appropriately before a scan tunnel, you're going to have side-by-sides, you're going to have misreads, you're going to have to recirculate those products, you lose the volume, you lose the efficiency of the sorter. So, you know, there's a real value to being able to upstream, be able to monitor through your sensors and feed that data to the cloud that, hey, I do have an issue, either alert maintenance teams immediately that an O-ring has to be replaced, a Anita belt has a problem, you've got a gearbox motor issue, but send the unsolicited message, maybe automatically populate a maintenance planner's report so that there's, during the next downtime window, they can address this. So, you know, basically, poor gapping throughout a facility is a killer of volume. Why not utilize cloud services? I threw a use case in there real quick. Obviously, what we're talking about today is logistics automation, but there's factory automation, package automation. These days, they have cloud-based services like Simple Workforce Service, SWF. What that does is if somebody, and I'll relate it back to logistics automation, if you have a picker doing something in a specific area and you have a need for basically, you know, a track and trace function or an automation function, or moving quality related data along with those cartons or totes, you now have these modules that are able to relate analog or labor functions with the process tasks. So I only wanted to mention it that, you know, this is where some retailers are starting really to look aggressively at, because of things like pandemics. They want to know, okay, if that workforce is an issue, you know, how can we bypass it, and what's that human, how can we implement around the human function? Another critical piece is, you know, when I walk through a facility and I talk to the maintenance team or the controls teams, probably the most intimidating piece within a distribution center is that darn scan tunnel. You know, it's a standalone tunnel. It's got its processor. You know, is it properly enunciated? What if a manufacturer sends your source is sending new boxes with different labels? What if your Panda, your print and apply, is printing poor labels? You know, a lot of times you can send a lot of product through, you can have a lot of misreads. Maybe you have a camera fail, maybe there's a hardware failure, but what happens is you can have a high volume of product that is not read and is either diverted to a hospital lane, reject lane, or recirculated, that reduces the efficiency of a scan tunnel. So when I say people are intimidated by this area of a facility, it's like, okay, are we utilizing a software that lets us have eyes into this process? Should I clean some mirrors? I'm looking, are the camera lights blinking? So when you have actual connectivity to the cloud, once again, you can send the unsolicited messages, you can send predictive messages to the appropriate teams that you have this problem, that there's a quality label issue, so that those teams can react quickly to remove that volume impediment because of the way that scan tunnel is being, how that scan tunnel is running. The other value is these days there's really low cost maintenance plans. Like SICK has a Connect product that basically while your local team is maintaining your material handling. We're also keeping an eye on it, and our support team also gets those unsolicited messages that, hey, we see in this facility on this tunnel that we're starting to see no reads. It's probably because of misalignment or side by sides because of an upstream issue. You know, we'll call your facility, we'll make the appropriate suggestions, we'll actually allow the team that's supporting that tunnel to go up to the control panel for them to use their smart device for us to see exactly what's going on and have and tell them what needs to be done to correct the problem. So let alone these are intimidating parts of a facility, you know, they're high volume loss areas. So, you know, you can, and these problems really can last for a whole shift for 20 minutes, 30 minutes. A lot of volume can get gained when you have this condition monitoring, these cloud connected tunnels that give you quick response and quick information on how to rectify the problem. And lastly, you know, besides the discrete sensors, besides you know, the scan tunnels, you know, companies are also really wanting to know, have they implemented a floor plan that is efficient? You know, we're adding more and more robots, we're adding more and more mobile platforms to move products, to move pallets. You know, is there a better way of redesigning the floor or implementing these new mobile platforms? SICK also has the mobile tags that can be placed on these mobile platforms so that you can see how efficiently those machines, those platforms are moving throughout your facility. Do things need to be changed? Do our industrial engineers need to be updated because we're having points of conflict? Are there safety issues? So once again, if you are constantly collecting this data, in this case, it can be more of a big data usage where our data scientists are getting back with a network industrial engineer saying, hey, this is what they see. How about moving these shrink wrap machines or doing this? You know, there's all sorts of sensors that can be utilized by your cloud services to improve movement of boxes and improve volumes for your DCs. So we wanted to keep, that probably went on way too long, but we wanted to keep the number of use cases to a minimum. So I appreciate your time today.
Yeah, thank you, Bill, and thank you, Brian. We're actually going to take some time here for a couple of questions that have come through. And just a reminder for the audience, please be sure to type any questions you have in that Q&A box on the right-hand side of your screen. So let me start off with the first one here. And it's regarding OEE metrics. The question is, I want to know more about OEE and how much I can do with all the data that I'm gathering.
Perfect. Well, what we typically do is we'll reach out to the customer, we'll talk with the appropriate planning groups, and we'll explain to them the data that we can populate, the tools that they can utilize, and you know, there is no clear-cut answer to this question because every retailer is a different place in this digital transformation. But what we do, SICK does, I think we do a pretty good job, is helping the retailer to build the technical roadmap so that we can show them how to utilize that data and how to get that data to where they want to utilize it. So
Great.
Basically it means us reaching out and having in-depth conversations to answer those type of questions.
Sure, okay. Thank you, Bill. And the next one is, does SICK provide the sensors and the engineering?
So I mentioned, you know, these are standalone systems. So truly, if you want a quick pace project, and these are quick pace projects, we really don't need the support of the initial integrator that developed these lines. But in a lot of cases, it's helpful to have them involved because, ultimately you may feed a lot of this data back into the material handling system. So SICK, for that reason, SICK does have an internal team to basically set up the hardware, set up the network connection from either the existing sensors or the new sensors to the local data hubs, to that device, local to that facility that supports, the cloud services. So we do have the engineering team. We're the largest supplier in the world of sensors. So we can supply both aspects to that question, but we can also work with that integrator who initially put in that material handling system.
Right. We do have a few more here. If we can continue on, it looks like we have the time. The next one is, what if we don't have a cloud infrastructure in place?
Once again, it goes back to that issue of, SICK's a sensor company. We're supposed to know about both our devices and utilization of those sensors and the future use of those sensors. So, every single conversation with the supply chain management team is different. So to answer that question specifically, in some cases, SICK is asked to obviously implement the hardware in place, but we're also asked to maintain that cloud space, that cloud VPC, to create the dashboards, to make changes. And, we can work simultaneously with the retailer, and when they're ready to set up their cloud environment, we can port it over, we can migrate that to their data center. In some cases, it's we've been asked, will you lease this functionality? Are there SLAs involved? We just, at the current time, we're not large enough, or we don't have the staff expertise to maintain this. In all of those situations, yes, we'll maintain it as long as the customer wants. We'll maintain the dashboards. We'll update the dashboards. But when the retailer feels comfortable of bringing that under their umbrella, by all means, we're quite ready to help them move that over to their system. Sometimes we're given not root admin, but security rights as a engineering team to move that over to their cloud space.
Okay, sure. And it looks like we're up against our last question here, which is, how do we determine which use cases are applicable for our DCs?
So I don't know if it's a typical setup, but as a account executive, we go through a distribution center. We'll say, hey, we'll engage your hardware. We'll walk through your facilities. We'll not only audit our hardware that's currently there or a competitor's hardware, but we'll go through at no cost to the retailer, no matter how many networks we go to. And we have trained eyes. We look for those lost volume and the associated part of hardware that's causing that lost volume. And we make those suggestions, depending on where they are. And by all means, these projects are very cost efficient. They're magnitudes less in cost than putting in an initial system because of the minimal hardware and software involved. But we'll go through, we'll make recommendations. So, some facilities may not even have a sorter, but they have, every facility, cross-dock, distribution center, factory supporting those cross-docks in distribution centers, they have labor issues. So we're trying to engineer around labor aspects that affect volume through a facility.
All right. Well, being that was our last question for the day, I want to thank you once again, Bill and Bryan, for presenting, and of course to our attendees for coming on to the webinar today. And I want to mention that upcoming webinars for Live from the Insights Experts series can be found on our sick.com website and in our newsletter. Just want to say have a great day, everyone.
Thanks, everyone.
Thank you.